This video is a review of prime factorization. Please make sure that you have your prime factorization video notes or your journal to take notes in. Pause the video whenever necessary so that you can stay caught up. Okay, let's review what prime numbers are. Prime numbers, they have only two factors, 1 and itself. Remember, factors are numbers that you multiply together to get a product or to get a certain number. So for example, 5. The only numbers you can multiply together to make 5 are 1 times 5 or 5 times 1. It doesn't matter the order, the factors are the same. The factors to make 17 are only 1 times 17. For 23, the only two numbers you can multiply together to make 23 are 1 times 23, and for 31, 1 times 31. There are no other numbers that you can multiply together to make 31. Okay, what about composite numbers? Composite numbers have more than two factors. So for the example 12, of course 1 times 12 will give you 12, but there are other factors or numbers that you can multiply together to make 12. So I always start with 1 and work my way up. I know 1 times 12 will give me 12. What about 2? Yes, I can multiply 2 times 6 to give me 12. I can multiply 3 times 4 to give me 12. My next number is 4, and I've already have the 4, so I'm done. There are no other factors that will give you 12. For 15, 1 times 15. Is 2 a factor of 15? Can I multiply 2 times the number to make 15? No. What about 3? Yes, 3 times 5 will give me 15. What about 4? No. 5? Yep, 5 times 3, which I already have right here. So once you start to repeat the factors, you know you're done. You've gotten all the factors that you can get. So let's go to 24. We'll start with a 1. 1 times 24. What about 2? 2 times 12. What about 3? 3 times 8. What about 4? 4 times 6. What about 5? Nope. What about 6? Oh, we already have the 6 right here. So we're starting to repeat, so we're done with the factors. We have found all the factors. Up here, is 2 a prime number? Yes, and it's very important to know that 2 is the only even prime number. Okay, all of the even numbers are divisible by 2. So the numbers would be divisible by 1 in itself, and then 2 and some other factor. With the exception of 2, it's the only even prime number, because the only factors that you can multiply together to make 2 are 1 times 2. So 2 is considered a prime number. Okay, so let's do some practice. We want to identify each number as either prime, and we can put a P for prime, or composite with a C. So 35. I know 1 times 35, so I'm just going to go up numerically. 2, it's not even, so it's not divisible by 2. What about 3? No, I know 3 times 11 is 33, and 3 times 12 is 36, but I can't make 35. 4 is not a factor. What about 5? Yes, 5 times 7. So this is a composite number. So, 42. Is this prime or composite? Well, I know that 42, this 2 is an even number. That means it's also divisible by 2, which would make it a composite number. 29 is not even. I know 1 times 29, and if I can think of any other factors, I know 3 times 9 is 27. So nope, 29 would be a prime. 19 is also prime. What about 130? Well, it ends in a 0. Any number that ends in a 0 is divisible by 5 or by 10. It's also, 0 is even, so it's also divisible by 2, which makes this definitely a composite number. Okay, prime factorization. Prime factorization is the breaking down of a composite number to show all prime factors using a factor tree. Okay, so to make your factor tree, the first thing you're going to do is write the number being factored at the top. In this case, 48 is our number. Step 2 is you choose a pair of factors. Any two factors whose product is the number being factored. So remember, factors mean that you're going to multiply them together. So I like to put a little multiplication symbol in between. 8 times 6 is going to give me 48. Are there other factors that will give you 48? Sure. 4 times 12, 2 times 24, 3 times 18. There are several factors that you can use. It doesn't matter which factors you use, as long as when you multiply them together, they make the 48. Then what you're going to do is you're going to factor all the numbers until they become prime numbers. And when they're prime, you circle. So I'm going to start with my 8. It's not prime. I could multiply 4 times 2 to make 8. And we know 2 is prime. It's the only even prime number, so we circle the 2. 4 is not prime. I can multiply 2 times 2 to make the 4 and circle the 2's because they're a prime. Then I come back to the branch with the 6. 6 is not prime, so I'm going to multiply 3 times 2 to make 6. 3 is prime as well as 2, so they are circled. Then the last step is you're going to write the expression using all of the circled prime numbers in least to greatest order. So when I look, 2 is my smallest number, and there are 1, 2, 3, 4 2's. So it would be 2 times 2 times 2 times 2, and then I have a 3 times 3. This is the prime factorization for 48. If you were to go back and multiply all these prime numbers together, you would get 48. Okay, so let's do a little bit of practice. What possible factors could you use to begin the factor tree to find the prime factorization of 60? Okay, we know that 1 times 60 will give us 60, but this isn't really a good pair of factors to start off with because you still have 60. So we want to start with something larger than 1. So you could start with 2. 2 times 30. You could also do 3. 3 times 20 would give you 60. You could do 4. 4 times 15. It ends in a 0, so that means it's divisible by 5. And 5 times 12 would give you 60. Then I go up to 6. I could do 6 times 10. 7 is not a factor. Neither is 8 or 9. The next number would be 10, which I already have. So now that I'm repeating my factors, I know that I'm done. These are all the factors that when multiplied together would give you 60. So when you're making your factor tree, you could choose from any one of these. It would not matter. You would still get the same answer. Okay, so let's go ahead and use a factor tree to find the prime factorization for these 3 numbers. Okay, so we're going to start with a 36. You can choose any 2 numbers that you want to, any 2 factors, as long as they multiply together to make 36. I'm going to start with 6 times 6. Neither one of these are prime, so I'm going to break each one down. 6 I can turn into a 3 times 2. Both of these are prime, so I will circle them. Then I have the 6 off of this branch, so I need to factor that. And I can do 2 times 3 or 3 times 2, it's the same thing. And they're both prime, so I circle. Now I'm going to write my prime factors, my circled numbers, in order from least to greatest. I have 2 2's, this is going to be 2 times 2, and I have 2 3's. Times 3 times 3. So this is the prime factorization for 36. So go ahead and pause the video, and in your notes use a factor tree and find the prime factorization for 70 and 45. When you found them, come back and check your work. Okay, how'd you do? The prime factorization for 70 in least to greatest order would be 2 times 5 times 7. And the prime factorization for 45 would be 3 times 3 times 5. If you did not get the same answers I did, please go back and check your work. Okay, one more example. Which of the following expressions shows the prime factorization of 750? So that's a pretty big number, 750. And we can use the factor tree to find the prime factorization. But sometimes you don't have to do that. Sometimes you can get the answer just by looking at your answer choices. A lot of times they're going to try to trick you. Remember, prime factorization, the key word is prime. All of the answers have to be prime. And if you look at answer choice A, is 10 a prime number? No, it's not. Is 25 prime? 25 is not prime either. Therefore, A cannot be your answer. Answer choice B, 2, 3, and 5, they're all prime. Let's go on to C. 3 and 5 are prime, but 6 is not prime. So answer choice C is out. And look at answer choice D. 75 is not prime either. So remember quarters, 3 times 25. So D is not your answer choice, which leaves us with answer choice B. Another way you can use the answer choices to help you determine if this is the correct answer is to multiply your numbers out. 2 times 3 is going to be 6. And if I do 5 times 5, that gives me 25. And then I can multiply 25 times 5 and get 125. Multiply that by 6, and that's going to give me 750, which is what we were wanting. Okay, now you're ready to do your independent practice.